Alright, right now we want to look at distinguishable permutations. Now, distinguishable permutations are when we have a set of objects that we're picking out specific things from them. So, for example, we're looking at a subdivision being built, and the subdivision is going to consist of 6 one-story houses, 4 two-story houses, and 2 split level houses. And so the subdivision is going to have 12 houses in it. And we want to know how many different ways we can build these houses that are stuck with this. They're stuck with getting one of these distinguishable things. And so how many different ways can we build this? Like a first story, second story, and so on. Making sure that these can be arranged. Let's see, we say first story, second story, split level, second story, first story. That's a way, right? The subdivision could be organized. There's another way it could be organized in a second, first, split, first, second. So I'm doing symmetries right now to show, but there's all these different ways that we can arrange these. And so how we end up finding these is we need to take the number of things we have and the number of each subset we have, each distinguishable thing we have here, to find those patterns. And so how we write that is we say n is the total number of things, n sub 1 is the total of one type, n sub 2 is the total of another type, I'll say type 2, right? Type 1, type 2, so on, all the way up to n sub k, right? If I have so many of them, total of type k. And the formula that we have for the number of permutations for this is we're going to take n factorial over n sub 1 factorial times n sub 2 factorial times all the way up to n sub k factorial. Now the thing to note that this n sub 1 and n sub 2 all the way up to n sub k has to equal n total. So notice we had 12 things here, and each type we chose added up to 12, 6 plus 4 plus 2. And so we can find all the different ways we can do this using this formula. So using this house example we have, all the different ways we can arrange the house in the subdivision would be 12 factorial times, or divided by, 6 factorial times 4 factorial times 2 factorial. And this is really let your calculator do the work for you. The calculator is the tool of choice here. So we'll come over to the TI here, and we'll say, hey, we had 12, go to math, and probability, and back down to factorial. And then that was divided by 6 factorial times 4 factorial times 2 factorial. And we find that we have 13,860 distinguishable ways, different ways that these 12 houses could be arranged in the subdevelopment. And the key, and I want to take away through all of these ways that we're doing this, is with the permutations, order matters. These have the exact same houses in them, right? But the order matters. What we're going to look at next is combinations where the order doesn't matter. And I'll put that up on the next video.